Section 4. Productivity in Python Development. In this section, we'll take a look at how we can be more productive as developers when working with Python. We'll first see how we can manage different environments in Python using built-in tools like Virtualenv. We'll then expand a bit on Python package management. We'll see how we can debug Python applications and explore the low-level Python bytecode. And finally, we'll see how we can use the Python Interactive Interpreter and Jupyter to quickly prototype ideas and share them with other people. Let's jump in. Managing Python environments efficiently. In this video, we'll take a look at what a typical Python installation looks like and how we can use Virtualenv to manage multiple Python environments without affecting the global installation. First things first, let's see what a typical Python installation looks like. We'll talk here about a typical install on a Unix-like operating system. Windows installs are a bit different, but the main things are still there. So what do we have here? There's three main things we need to know about. The Python executable. This is the entry point when using Python. The Python executable is basically the client interface to get our Python code running. The Python library. This is pretty much where all the Python magic happens. The Python implementation is usually found in this library that the main Python executable uses to run your actual Python code. And Python site packages. This is a folder usually found in the libraries folder of your system that contains all the installed Python packages. This includes the standard Python packages like OS, socket, threading, and other packages that you install from external sources. So this is a typical Python installation. But why do we need this information, you may ask? Well, let's see a hypothetical issue. We have a Python application that needs the requests package to run. We have Python 3.6 installed on our system, and we also proceed to install the requests package in our Python site packages folder. Our application runs just fine, and we're super happy. We then start developing a bunch of other applications ourselves that have different external dependencies. Our site packages folder will increase and have all the necessary packages and versions installed to run all of them. Finally, we want to run one of our applications on an external machine that does not have any of the packages installed. What do we do? How do we find out which of the dependencies we have installed is actually the one we need? Imagine that this application has hundreds of Python modules, all of which have different imports, so going through all the code is not a good idea, nor is going through the site packages folder or the pip freeze method, since we'll see all the installed Python packages. How do we fix this? Virtualenv is one of the tools we can use. So what is Virtualenv? Virtualenv is a Python utility that helps you create, well, you guessed it, virtual Python environments. A virtual environment is a Python environment that is based on symbolic links to an actual Python system installation. This is how it works. It creates symbolic links for the Python executable, and it will create a separate site packages folder where you can store modules that will not interfere with the system installation. When you use Python this way, you will have separate site package folders for each environment. So moving applications from one machine to another and finding dependencies is a breeze. Let's see it in action. If you remember from the very first section, we created a histogram calculator, which we ran using Python 3 and PyPy. This was the module that we created in section 1. Let's create a Virtualenv to run this separately from our system install. We'll create the Virtualenv, give it a name, and that's it. Create it like so. Now we have a Python 3 Virtualenv installed in this folder. Let's see what's inside. We have a bin folder with our Python executable and pip. We have an include folder for any external Python C module headers, empty in our case here. And we have a lib folder where we can find just a few extra packages in our site packages folder. Cool stuff. So how do you use it? You can use it by running the binaries from the Virtualenv instead of the system libraries. So for example, we'll use this interpreter instead of the actual Python. But luckily, there's a handy activation script that replaces the regular calls with the Virtualenv ones in our current shell session. all we have to do is source that script. Inside the bin folder, you have an activate script. As you can see, our prompt has changed so that we know that we have a Virtualenv active in this shell. As you can see, when running Python, we have another path instead of the system one. We can now use Python normally. We'll install Pillow as needed by the histogram calculator and run the script. You can see that it works. We're using the symbolic link of the Python system install, and we installed Pillow in a local site packages. So let's see if that is really the case. We can see here in this site packages folder that we have the pill package that we use inside our script. Let's see the system install. We can see here in the global site packages folder that we don't have a pill package. We can even test this by deactivating the virtual environment and running again. So we'll deactivate our virtual environment. We'll navigate back to our histogram calculator. And we'll run this with the system installed, where we don't have pill installed. As you can see, we did not pollute the system packages with the package we needed for this application. If you remember from the first section, we used this application to see how we use PyPy. So can we use Virtualenv with PyPy? Of course, we'll run the same thing. So we'll create a PyPy Virtualenv. We'll activate the new environment. Let's open the interpreter. We can see here that we're running PyPy here instead of Python. So even if we run the Python or Python 3 command, we're still running PyPy. So everything is linked together with the interpreter that we chose when we created the virtual environment. We'll install Pillow next and then run the application. So let's run the application again. This time running a Virtualenv where we have PyPy. So we're going to run this using PyPy. As expected, it runs faster with PyPy, and with Virtualenv, switching between environments is a breeze. All I have to do is activate the virtual environment that I need. If I deactivate the PyPy one, I can just go ahead and activate the regular one, the Python 3 one. And that's it. I just switched between environments very easily. There are a few more things to mention here. Virtualenvs are usually placed at the root of your project, and they are not checked into source control, so make sure you add the Virtualenv folder in gitignore or the like. Another popular way of managing Virtualenvs is to keep them all in one single folder outside the projects. You don't have to add them in gitignore, and you also don't suffer from the next thing. You cannot move or rename the virtual folder. I mean, you can do it, of course, but it won't work anymore. The path is hard-coded, so any change in the path will break the Virtualenv installation. Virtualenv is not the only tool to manage multiple Python environments. Virtualenv is built in Python now, and it's very easy to use. But there are also third-party tools like Virtualenv Wrapper, which use Virtualenv but offer even easier ways of managing environments, so check that out as well. That's it for Python environments. To recap, in this video we've seen what a typical Python install looks like, and we've also seen how to use Virtualenv to manage specific environments for each application.